Hello students, today we are going to discuss on hardware descriptive language, which is very important for your VLSI design course. Here I am going to start with the very basic syntaxes of your hardware descriptive language that can be used for mainly designing combinational as well as sequential circuits using logic gates by the programming of HDL. We call it as very hardware descriptive language, that is VHDL. So here, if we quickly move ahead with this, we can see that while doing the uh, programming, we need to understand that we have got certain modeling which is very important in order to understand the Verilog codes. So here, as you can see, that there are three modelings are there. One is data flow modeling, that is a very basic one. Second is behavioral modeling, and third one is structural modeling. So today I am going to discuss about the data flow modeling, behavioral modeling and structural modeling separately so that you can understand the comparison between these two. So going to the data flow modeling, it is something that by means of which we can design any basic gates whose only input and output information is given. If the same designer can have the information of the behavioral pattern of that particular gate, then the designer can go and opt for behavioral modeling. So as the structural modeling, here the case is slightly complex. We use this modeling only for complex circuits where multiple amount of gates, transistors are involved into it, and the designer do not have any idea of about each and every module's behavior. If the designer do not have the idea of the individual behavior, so generally we opt for structural modeling. All the three modelings are perfect for hardware descriptive languages. Let me go with the data flow modeling, and I am keeping it very simple because this will help for the beginners. So I have taken a snapshot of one very basic book of VLSI design, where here we can see that the data flow modeling is because mainly it is opting for the input and output. We need to identify the inputs and output. So here we can see the module, as we can mention over here, module, then my end in bracket y comma a comma b. What does it mean? I want to design a AND gate. So as we know that if we want to design a basic AND gate is having two inputs and one output. So we have to write down the module. We have to design the module by naming the name, where the name is, it is the variable name, anybody's name it can be, but please do not write down only AND, A-N-D, because if you write down only AND, it can fetch the logical AND gate from the library and give you the garbage value, so that it is same as programming C, where any variable name you can opt for. Here I have written my end, like you any name you can give it to it, and after that you have to assign the brackets, where in that particular brackets the input and output combination need to be there. Here it can be clearly visible that y is the output I am identifying and a and b are the inputs. So I have to identify also that input and output, and lastly I have to assign them, assigning the value. So a ampersand b, it means that the logical AND operation between a and b logic will be performed and will be given to y, and then I have to finish the module with n module. So here I have to write down n module. So this is the very simple basic two input AND gate modeling using Verilog HDL. And here I wanted to mention the propagation delay. Just you keep this thing in mind. This will be helpful for my later videos, where this delay will come into existence. It plays a major role. If you place where and then hash 1 means hash 1 is identifying 1 nanosecond, hash 2 2 nanosecond, hash 3 3 nanosecond, like so as. So what it will perform is that the first operation between A and B will be given to y1, and that will be connected to y2, where the second operation will be performed after 2 nanosecond, so as the third operation will be performed after 3 nanosecond, and the final operation will be performed after 2 nanoseconds. So totally it will be of 2 1 is 3, 3 plus 3 is 6, and then plus 2 is 8. So after 8 nanosecond my output will be available to my screen, and then I have to finally end using end module. So this is how the propagation delay need to be added if it is a complex gates. I am not going to it right now. I am going for a very basic model. So the same thing I have mentioned here. If you can see my slide, where you can clearly have an idea that it is a data flow modeling of an half header, where again I have written the same thing module. Then I have given the name as a HA, that is half header data. Data means data flow modeling, and then I have mentioned here in the bracket that what is the input and what is the output. So from the name you can clearly understand that A and B are the inputs and A sum and carry are the outputs. I have identified similarly input A comma B and output is sum and carry. And then as it is a data flow modeling, so I will keep it simple. Only the assign structure, assign uh, uh, part will be enough for us to understand that assigning means the operation will be assigned to output sum. Similarly, this operation, that is A ampersand B, will be operation and performed and to be assigned in carry. So like this way, here it is assigned sum A and cap then B. It means that you can also write down that sum equal to A XOR B, and this is the symbol. You can use the symbol also. You can write down the notifications also. If you can write down here X or XOR then space, automatically it will become blue if you type it in your programming data sheet. Okay, I have written, you cannot see here it will blue because I have made it in PPT. If you can use it in your desktop using the software, you can easily go for it and you can check that exactly the XOR letter, I mean this color will become blue because the XOR letter is already there in the library file. So as I have to make similarly as carry A and B and N module. So this is very simple one. So here we can have an idea that ultimately what we are doing in data flow modeling is to assign the values. First we have to identify the input and outputs, and then we have to write down only the assign. If I write down assign, that means the operations will be assigned to the output, and automatically if you place it in module, the whole programming can be uh, able to perform the output. Now today I am going to show you the behavioral modeling. Here in the behavioral modeling, only difference we need to understand that if I opt for behavior modeling, I need to know about the behavior of the target object. Target object means in VLSI design we say whatever the module we are going to design, this is the target object of the VLSI designer. So same here also I have to write down module, then HABEH. I have mentioned the name as like this as a behavioral modeling, and identified all the input outputs. So as I have done the similar case in the data flow modeling. The only difference between behavioral and data flow is that I have to write down reg, that is register. Reg means it is register. Register means it will store the value. Sum and carry, this output data, output values will be stored in the register always at given inputs. So here I have mentioned always at, what are the inputs? Two inputs. If it is a half adder, that means if it is a two input half adder, so A and B, so for always at the combination of A or B, and then we have to write down begin, and we have to also write down the operations here, sum and carry. So here as we can see that the XOR operation of between A and B is performed in sum, and AND operation A ampersand B is performed in carry. But here remember one thing I am telling you, that here we do not have to write down assign as we are writing here in data flow modeling. Here we are writing assign, but in case of behavioral modeling we do not have to write assign. If you write down the only operation, obviously in the loop or in the context between begin and end, we have to understand that things will be done. So please remember, this is the basic difference between behavioral as well as data flow. Here we are writing assign, and then we have to write down the operations, but in behavioral modeling we do not have to do so. In begin we have to start and we have to end with this writing only the operations. Once we end the operations information, then also we have to end the module also. So I have to write down end module, then semicolon. So semicolon performs the line breaker, as we know that we have already done this thing in the basic programming of C. So hope this video helped you a lot for a beginner. Obviously in coming lectures we will also let you know about the little bit of complex circuits, where I will show you the structural modeling, and also we will discuss about the uh, second layer, three layer, combinational as well as the sequential circuits, and finally how to make the combination of both in case of performing this in a hardware descriptive language altogether. So thank you very much for listening this video. Hope these slides have been helpful to you.